Okay, now we're going to talk about the frequency scan measurement of the Agilent X Series EMI receiver application. So emissions measurements basically consist of three parts: scanning, searching, and measuring. In the frequency scan measurement, mesh setup allows you to configure many of the parameters of the scan, and one of the most important is the scan sequence. So using the scan sequence, you can set the analyzer to do a scan, a search, a measurement, a final measurement, or you can set up combinations of these using the scan, search, and measure, or the scan and search, etc. soft keys. So right now, we're going to use the receiver application in its preset state, which is the scan functionality. So I'm in scan only. If I hit restart, I'm just going to start scanning. So you can see that using the AmpCore factor that I loaded earlier, it drops off at about 300 megahertz, and so when you turn it on, it has an effect up to about 300 megahertz, and then it stops. Okay, so the heart of the scanning function is is the scan table. Using the scan table, you can configure most of the parameters of the scan, basically all of the ones that aren't global to every range. You have 10 distinct frequency ranges. You can scan over any or all of them, and within the scan range, you can configure the start frequency, stop frequency, the res bandwidth, and the res bandwidth can be automatically set to auto couple to the center frequency. You can see that in range 1, which is basically CISPR band A, it auto couples to 200 hertz. You can also set the dwell time and the step size for each range, and the step size couples to the res bandwidth using the points per res bandwidth function. This defaults to 2, so you can see that with 2 points in a 200 hertz res bandwidth, I'm going to have a 100 hertz step size. And then the dwell time couples to the res bandwidth and the step size. You can set the attenuation for each range, and you can set whether the internal preamp is on or off for each range. And if you have an analyzer that has multiple inputs, you can set the input you want to use for each range. Okay, so the default range is range 5, which is CISPR bands C and D. Goes from 30 megahertz to a gigahertz with 120 kilohertz res bandwidth, therefore a step size of 60 hertz. If I change the points per res bandwidth to, say, 4, then you can see that my step size changes to 30 kilohertz. But let's just go ahead and use 2, which is the default. Okay, so we're going to sweep over range 5. You can actually sweep over multiple ranges. For example, if I enable range 2, and you can do this with a mouse, or you can do everything also with the soft keys. Range 2 on. Now, if I restart, you'll see that I'm sweeping over range 2, and it's using a 9 kilohertz res bandwidth, so it's a little slower than the scan over range 5, which is using the 120 kilohertz bandwidth. And you can see that as it's scanning over each range, the annotation shows you what bandwidth it's using. And then when you stop the scan, if it was a multi-range scan like this one, you have this green box that shows you what the annotation is referring to. So this is range 2, and you can see that the annotation is reflecting the measurement settings that were used in range 2. Or if I go to the View Display menu and select Next Range, then it shows me the measurement settings that were used for range 5. So the flexibility to scan over multiple ranges, part of the N6141A receiver application. I'm going to go back to the scan table, and we're just going to use range 5 for the rest of this demonstration. Now, of course, once you've got the scan table the way you want it, it's easy to save the scan table to mass storage and load it back in anytime you want to use it. I should also point out that when you're actually scanning, you can make changes to the scan table provided that you're using a single range scan. So if I decide that I want to change the attenuation while I'm scanning so I can see what attenuation I want to use, first I can turn off the display of the scan table. Then you can see that I can adjust the attenuation down or up, and you can see that the attenuation will actually change while I'm scanning, and this can allow me to adjust the attenuation so that I'm getting the exact scan that I want. And you can do this while you're scanning, which is not possible with any other analyzer. Other things that you can do while you're scanning, you can do your peak search of your marker. You can move the marker around on the display while you're scanning, and again, this is not something that you can do with any other analyzer. So you being able to use the marker, adjust the attenuation, adjust the reference level while you're doing your scan are more usability features that you only get with the X series analyzers. Now, I mentioned that there were some parameters that you adjust outside the scan table. One of these is the step control function. If you want to see what your overall scan time is and number of points, then you can change the step control to scan time and points from step size and dwell time. And that can help you if you want to look at what your overall scan time is. And also setting up the detectors that you're going to use for the final measurement. That's done under Mesh Setup. We'll talk a little bit more about that when we get to the measure portion of our frequency scan training, and also the detector that you're using for each trace. And again, you can scan with multiple traces. You can scan with a clear right trace and an average trace at the same time by going into the trace menu and turning on another trace. And also, you pick the detector that you're going to use for the pre-scan by going into the trace menu. And so for trace 1, which is the yellow trace, I'm using the peak detector for my pre-scan. You can see that other detectors are available for the pre-scan, but of course with the peak detector you're going to get your fastest scans. Now here I'm going to pick the average detector for trace 2's pre-scan. You can also turn on max hold in the trace menu. I'm doing a max hold right now on trace 1. And a lot of people like to use max hold to capture intermittent peaks. Okay. So let's preset the frequency scan measurement and restart the scan. Turn the limit back on, and I'm going to show you how you can zoom in on a signal. So let's use peak search to find the strongest signal on the display, and then under marker function we have this marker zoom function, which lets you zoom in on signals while you're scanning. And you can get in pretty tight. At this zoom level, you can actually see the step size resolution of 60 kilohertz. When you zoom all the way in, you can get some real insight into what's happening in your scan. So you can use the marker to zoom in at any point on the scan at any time while you're scanning, and this can help you understand what's going on while you're in the middle of a scan. Now when you stop your scan, then the meters come into play again. And because I did a preset, meters 2 and 3 turned off, I'm going to go turn them back on for the rest of our demo. Okay. Oh, and remember that you can move the meters to the marker at any time by doing the marker to meters function. I know that seems a little backwards. You might think it should be meters to marker, but you have to think of it as moving the marker value into the meters in the same way that marker to center frequency works in the spectrum analyzer. When you do a marker to center frequency, it moves the marker value to the center frequency. Also notice that the the meters being vertically placed next to the display line up with the frequency scan very nicely, so that the same amplitude axis that applies to the scan also applies to the meters. So those are some of the basics of scanning, and now we're going to move on and talk about searching.